All right, so on this next one, kind of similar to how we did the first one, we're going to try to do factor by grouping, and you'll very quickly see that this doesn't work. So I'm going to do it real quick, and then we'll erase all this work. So if I try factor by grouping, I take out, these two terms have x squared in common. So when I take that out, I would have x plus 9 left over. These two terms, all they have in common is 2. So if I take a 2 out, all I have left is 13x plus 12. Since these do not match, those two groups do not match, I can't use this method of factoring here. So I am going to erase all of this. Whoops. So I'm going to erase all this, and we're going to kind of start back at the beginning with our original problem. Okay, so now, since factor by grouping did not work for this problem, the only way that I can technically find all of my solutions in order to factor this completely without a calculator, like by hand and doing everything like Apex kind of explains it to you, is doing the rational root theorem. So P over Q, we would find all the possible rational roots by finding the factors of our last term divided by the factors of our first coefficient. So the factors of 24 are plus or minus 1, 2, 3, 4, 6. So think of all the numbers that go into 24. And then 8, and then 12, and then 24. So 1, 2, 3, 4, 6, 8, 12, 24. And then on the bottom, factors of our leading coefficient right here is 1. That would just be plus or minus 1. So all of our possible rational roots are 1. So you divide like all the numbers on the top by all the numbers on the bottom. So plus or minus 1, 2, 3, 4, 6, 8, 12, and 24. Those are all the possible solutions. So technically we have 1, 2, 3, 4, 5, 6, 7, 8 numbers, and there's a positive and a negative version of each of those. So there's 16 possible solutions, okay? Now technically what you would do, you would start with 1, and we would do synthetic division with a solution of positive 1, and do synthetic division with this, see if it has a remainder of 0. If it does, we know that it's a root, and it would therefore be a factor. And then we could do something else with that, okay? So if I did that, I would find that 1 does not work. Then I would do negative 1. Negative 1 also does not work. Then I would do 2. 2 does not work. Then I would do negative 2. So I'm kind of skipping a bunch of work just until I show you the ones that do work. So if I do negative 2, synthetic division with my original equation, my coefficients are 1, and then, so 1 here, 9, 26, and 24. And so I want to show you kind of this shortened process, okay? So I bring down my 1, I multiply. Negative 2 times 1 is negative 2. I add these, 9 and negative 2 is 7. Multiply, I get negative 14. Add down, I get 12. Multiply, I get negative 24. Add down, and I get 0, and that's good because that's my remainder. So we found our first solution is negative 2, okay? Now, when I have negative 2, that makes this, I take this and I write my equation. So this is 1x squared, this is 7x, and this is just a number by itself. It's my constant, okay? So what that means is that if negative 2 is a solution, I can write my factor as x plus 2. Remember, in factored form, it's always, the signs are always opposite. So if your solution is negative 2, your factor is x plus 2. Then the rest of this, in terms of factorization, would be x squared plus 7x plus 12, okay? So we're taking, again, this leftover, like these leftover coefficients with this. So this becomes a factor, and this is our other factor. And then we have to see if we can do anything else with this. So this, I'm good with x plus 2. That's already factored completely. This, I want to see, can I factor it anymore? So are there factors of 12 that add to give me 7? Yeah, there are. 3 and 4 multiply to give me 12 and add to give me 7. Okay? So, and we're not solving this one, so that's actually it. We don't need that where it's set equal to 0. So x plus 2, x plus 3, x plus 4, if you multiply all of that out, you get at the very top x cubed plus 9x squared plus 26x plus 24. Okay? All right. Okay, so we're going to do the next one here. And again, I would first try at least to do factor by grouping, because if it does work, it is a lot less complicated. So I'm going to group my first two, group my last two. I'm going to put a plus sign in the middle so I know that those are, I included the sign with a negative x, but I know they're being added together. I'm not multiplying those. All right, so this first set of terms, I can take out an x squared, and then I'd have x plus 4. This second set of terms, they're both negative, so I'm going to factor out a negative 1, and then I still, again, have x plus 4. So x plus 4, those match. That's good. We want them to match if possible. So x plus 4 is my first factor. My second factor we make from like the GCFs that we pulled out. So x squared minus 1. Now this one's good, kind of like our last problem. I can't do anything else with that. I can factor this. This is the difference of squares. So to factor that, I have x plus 1 and x minus 1. Okay, and then that would be your answer. If you multiply that all out, you get the original problem that we started with. Okay.